Linear programming problem, graphical method. In the previous video, I have explained maximization problem with two constraints. In this video, I am going to explain minimization problem and maximization problem. In minimization with two constraints, in maximization with three constraints. Let us see the problem. Solve the following LPP using graphical method. Minimize z is equal to 4x1 plus 6x2 subject to x1 plus x2 greater than or equal to 8, 6x1 plus x2 greater than or equal to 12, x1 and x2 greater than or equal to 0. This is a minimization problem. Our objective function is minimize z is equal to 4x1 plus 6x2. So, our final answer will be the optimum value. So, let us see. First, you need to convert the first constraint into an equation. x1 plus x2 is equal to 8. Okay, I have converted the first constraint into an equation. So, now we need to find the value for x1 and x2. So, first you need to consider x1 as 0. So, when x1 is equal to 0, what is the value for x2? We need to find the value for x2 when x1 is 0. Just substitute this value in the first equation. So, x1 value is 0 plus x2 is equal to 8. So, x2 is equal to 8. So, we have got x2 value. In the same way, when x2 is equal to 0, what is the value for x1? We need to find the value for x1. Now, substitute this value in the first equation. So, x1 plus x2 value is 0 is equal to 8. So, x1 is equal to 8. So, we have got the value for x1. So, in the first thing, x1, x2. Okay, so we need to have 2 points to draw a line in the graph. When x1 is 0, x2 value is 8. When x2 value is 0, x1 value is 8. So we have got 2 points. With this, you can draw a line. Now, look at the second one. 6x1 plus x2 greater than or equals to 12. No, convert into an equation. 6x1 plus x2 is equal to 12. So, second equation. x1 is 0. What is the value for x2? Just substitute. 6 x1 value 0 plus x2 is equal to 12. 6 into 0, 0 plus x2 is equal to 12. So, x2 is equal to 12. Now, when x2 is equal to 0, what is the value for x1? Just substitute this value in the equation. 6x1 plus x2 value is 0 is equal to 12. So, 6x1 is equal to 12. x1 is equal to 12 divided by 6. So, x1 is equal to 2. So, we have got the value for x1. x1 is 2. When x1 is 0, see, when x1 is 0, x2 is 12. The same way, when x2 is 0, x1 value is 2. So, we have got 2 points. So, with this, you can draw a line. Now, I am going to draw a line for first equation. See the value. x1 value is 0. x2 value is 8. This is the x1 axis. This one is x2 axis. So, first point is x1 0, x2 8. Second point is x1 is 8, x2 is 0. x1 value is 8, x2 value is 0. So, this is the point. Now, we need to join the 2 points. Now, see the values for second equation. x1 is 0, x2 is 12. And the second point is x1 is 2, x2 is 0. For second constraints, first point is 0, 12. That is x1 is 0, x2 value is 12. This is the point. Look at the second point. 2, 0. That is x1 value is 2, x2 value is 0. So, this is the point. Now, we need to join the 2 points. See, this line represents the first constraint and this line represents the second constraint. So, now you need to find the feasible region. Look at the first constraint. Greater than or equal to 8. Second one also greater than or equal to 12. When you find the feasible region, just check whether it is lesser than or greater than. So, both the constraints are greater than, which means the feasible region should be above the two boundaries, that is two lines. See, both the constraints are greater than or equal to. So, the feasible region must be above the first constraint as well as above the second constraint. This is the feasible region. See, this is the feasible region. Here we have three corner points. This is the first corner point, second corner point, third corner point. A's value is 8 and 0. That is, x1 value is 8, x2 value is 0. And C's value is x1 value is 0, x2 value is 12. And look at this. This is the point which intersect both the lines, both first constraint and second constraint. So now we have to find the value for B. See, x1 value is 0.8. x2 value is 7.1, 7.2, 7.2. A, B, C. So in the feasible region, we have three corner points. The optimum solution will be any one of the corner points. Let us find the optimum solution by substituting the three values in the objective function. See, these are the three corner points values given. Now we need to substitute this value in the objective function. Our objective function is minimize z is equal to 4x1 plus 6x2. Now we need to substitute these values in the x1 and x2. Let us see the first one. A's value is 8 and 0. x1 value is 8, x2 value is 0. Z A is equal to 4, x1 value 8 plus 6, x2 value 0. 4 into 8, 32 plus 6 into 0, 0. So answer is 32. In the same way, find the value for B also. So ZB is equal to 4 into x1 value is 0.8 plus 6, x2 value 7.2. Okay. 4 into 0.8, 3.2 plus 6 into 7.2, 43.2. So what is the answer? 3.2 plus 43.2 is 46.4. In the same way, find the value for C also. 4 into x1 value is 0 plus 6 into x2 value is 12. So 4 into 0, 0 plus 6 into 12, 72. So what is the answer? 72. Okay, now we have got the value for three corner points. For the first one is 32, for B 46.4, for C 72. Okay, so since the type of objective function is minimum, the solution corresponding to the minimum z value is to be selected as optimum solution. So look at which one is least value, 32 or 46.4 or 72. 32 is the least value. So this point is the optimum point. This is the optimum value. So optimum solution is A. Optimum solution is A. Point A, that is corner A, is the optimum solution. So x1 is equal to 8 and x2 is equal to 0. Z optimum value how much? 32. Okay, this is the optimum solution. Here I am going to explain third model in LPP graphical method. So this is the maximization problem with three constraints. Take the first constraint, make it as an equation. 5x1 plus 10x2 is equal to 50. So find the value for x1 and x2. When x1 is equal to 0, what is the value for x2? So just apply this value in the first equation. 5 x1 value is 0 plus 10 x2 is equal to 50. So 5 into 0, 0. So we have only 10 x2 is equal to 50. So x2 is equal to 50 divided by 10 is equal to 5. So when x1 is 0, x2 value is 5. In the same way, we need to find the value for x1 when x2 is 0. When x2 is equal to 0, what is the value for x1? Okay, just apply this value in the first equation. 5x1 plus 10 x2 value is 0 is equal to 50. So 10 into 0, 0. We have only 5x1. So 5x1 is equal to 50. x1 is equal to 50 divided by 5. So what is the value? 10. So x1 value is, when x2 is 0, x1 value will be 10. See the second constraint, 8x1 plus 2x2 greater than or equal to 16. Make it as an equation. 8x1 plus 2x2 is equal to 16. So we need to find the value for x1 and x2. When x1 is 0, what is the value for x2? 8, x1 value is 0 plus 2x2 is equal to 16. 8 into 0, 0. So we have only 2x2 is equal to 16. So x2 is equal to 16 by 2. So what is the value? 8. So x2 value is 8. In the same way, when x2 is equal to 0, what is the value for x1? 8 x1 plus 2, x2 value is 0 is equal to 16. So 8 x1, 2 into 0, 0 is equal to 16. So x1 is equal to 16 divided by 8. What is the value? 2. So x1 value is 2. So when x1 value is 0, x2 is 8. When x2 is 0, x1 value will be 2. So we have got the value for second equation also. In the same way, find the value for third equation also, that is 3x1 minus 2x2 greater than or equal to 6. 3x1 minus 2x2 is equal to 6. So find the value for x1 and x2. When x1 is equal to 0, what is the value for x2? Let's apply this value in the equation. 0 minus 2x2 is equal to 6. 3 into 0, 0 minus 2x2 is equal to 6. So x2 is equal to 6 divided by minus 2. So x2 is equal to minus 3. When x1 is equal to 0, x2 value is minus 3. In the same way, when x2 is equal to 0, what is the value for x1? So when x2 is equal to 0, what is the value for x1? 3x1 minus 2, x2 value is 0, no? 0 is equal to 6. So 2 into 0, 0. So we have 3x1 is equal to 6. So x1 is equal to 6 divided by 3, 2. So we have got 2 points. When x1 is equal to 0, x2 value is minus 3. When x2 is 0, x1 value is 2. So with this you can plot the line in the graph sheet. See, in the first equation we have got 2 points now. When x1 is equal to 0, x2 value is 5. Okay, when x2 is 0, x1 value is 10. So with this 2 point you can draw a line. When x1 0, x2 value is 5. So 0 and 5. So x1 value 0, x2 value 5. This is the first point. See the second point. x1 10, x2 0. x1 10, x2 value 0. So this is the point. x1 10, x2 0. So we have got 2 points. With this you can draw a line. First line. Join the 2 points. This line represents the first constraint. Look at the second constraint values. x1 is 0, x2 is 8. x1 0, x2 8. So this is the point. x1 0, x2 8. This is the first point. x1 is 2, x2 is 0. x1 is 2, x2 is 0. This is the second point. x1 is 2, x2 is 0. So now you need to join the 2 points. This line represents the second constraint. Look at the third equation values. x1 is 0, x2 is minus 3. So the first point is x1 0, x2 is minus 3. This is the point. See, x1 0, x2 minus 3. This is the first point. Look at the second point. x1 is 2, x2 is 0. x1 is 2, x2 is 0. So this is the point. That is 2, 0. This is the second point. Now you need to join the 2 points. See, this line represents third constraint. So we have got 3 lines. Now you need to find the feasible region. So before you find the feasible region, just see the 3 constraints. Check whether it is greater than or less than. Based on that only you can able to find the feasible region. Look at the first equation, that is less than or equal to 50. Okay, so less than or equal to means the feasible region must be below the first line. That is, first one is below. And look at the second equation here, greater than or equal to. So greater than or equal to means the feasible region should be above. Look at the third one, that is greater than or equal to 6. So the third line is greater than, no. So above. The feasible region should be above the third line. Okay, the first one is less than or equal to. So, the feasible region should be below the first line. Second one, greater than or equal to, no. So, the feasible region should be above the second line. And third one also greater than. So, the feasible region should be above the third line. So, with this, we can able to find the feasible region. This is the first line. Okay, the feasible region should be below this line. Just shade like this. So the feasible region should be below the first line. Okay, now go for the second line. Look at the second equation condition, that is the feasible region should be above this line. See the second line, the second constraint rule is the feasible region should be above the second line. So erase the below shaded portion. See, the first constraint condition is below the line. The feasible region is below the line. Second constraint condition is above the line. The feasible area will be above the line. So, 2 conditions are satisfied. Now, go for the third one. Look at the third constraint. The condition is above. Okay, the feasible region should be above this line. This is third constraint. Okay, the feasible region should be above this line. That is above this line, no. So this is the inner side, this one is outer side. Okay, the feasible region should be above this line. So erase this part. Third constraint condition is the feasible region should be above the third line. So this is the final feasible region. This feasible region you have found based on the 3 conditions. First condition is it should be below the first line, above the second line, and above the third line. This is a feasible region. In this feasible region, we got 3 corners, A, B and C. Now, find the x1, x2 value for each corners. For A, x1 is 2, x2 is 0. For B, x1 is 10, x2 is 0. For C, x1 is 4, x2 is 3. So, x1 value is 4, x2 is 3. Now, substitute 3 corners of the x1 and x2 values in the objective function to find optimum solution. Objective function is maximize z is equal to 100x1 and 60x2. So, these are the 3 corners x1 and x2 values. Now, substitute these values in the objective function. za is equal to 100, x1 value is 2. Plus 60, x2 value is 0. What is the answer? 100 into 2, 200 plus 60 into 0, 0. So, answer is 200. For B, 100 into x1 value is 10 plus 60, x2 value is 0. 100 into 10, 1000 plus 60 into 0, 0. So, answer is 1000. For C, 100 into x1 value is 4 plus 60 into x2 value is 3. 100 into 4, 400 plus 60 into 3, 180. Total 580. Since the type of the objective function is maximization, the solution corresponding to the maximum z value is to be selected as the optimum solution. Look at the z values. A value is 200, B value is 1000, C value is 580. So, B value is the maximum value. Hence, the corresponding solution is x1 is 10, x2 is 0. Z optimum value is 1000. In this video, we have discussed minimization problem with 2 constraints and maximization problem with 3 constraints. Hope you all understand this concept. Thank you.